This week I'm here with Donn Silberman, and Donn has, to put it briefly, a very extensive background in optics. He's currently involved in volunteer work, outreach programs, and it sounds like enjoying retirement. So Donn, I've gone through your list. It's too long. I'm going to get things wrong. So why don't you tell us how you got into optics?
So that's very straightforward, actually. Like many young people, when I was in high school, I was fortunate to be able to take an astronomy class my junior year in high school. And I just fell in love with astronomy. I was introduced to the galaxies and black holes and quasars and telescopes and heliostats and even a planetarium. And it just became, an obsession. And I just wanted to learn as much as I could. And my senior year, I became a student assistant to the teacher. So I was able to, do planetarium shows, take care of the telescopes, teach my fellow students about things. And I applied to the University of Arizona to go to study astronomy. I was accepted. And I went there and I loved Arizona, although I did end up transitioning to physics and then engineering physics, and did a lot of stuff with lasers. My last 2 years, I worked at the Optical Sciences Center as a student technician, and became the Society of Physics Students president my last 2 years at the university there, and just did a lot of great things, including joining OSA, the Optical Society of America, now known as Optica, probably in 1982 when they had their annual meeting in Tucson. And they asked me if I wanted to host a presentation of some type. And my freshman year, I had an independent astronomy study class with a gentleman named Professor Nick Wolf. And he was, by the time 1982, he was the acting director of the Multi-Mirror Telescope Project, which was the very first multi-mirror telescope up on Mount Hopkins.
Oh, wow.
And so I asked him if he would be a speaker, and he said yes. And it was a really amazing event. I didn't know what I was doing, but I just did it, and it worked out great. And I became an associate counselor of the Society of Physics Students the following year, came back and drove a busload of students from several states up to Kitt Peak. Well, by the way, when I was in summer between junior and senior year in high school, my dad was living in Tucson. I was living in Los Angeles with my mother. And when I visited him, he took me up to Kitt Peak. So it was just a slam dunk. It's just like, this is what I'm going to do.
Right.
And I've been doing very related things all my career, many times working on components and instruments for large telescopes. So it's been fun. And then my first job out of college, I was a laser engineer for Melis Griot laser products. And then I did laser applications and medical optics with intraocular lenses with Johnson & Johnson when I got my master's in technology management, because I really didn't think that some of the managers that I had earlier in my career weren't really knowledgeable about management or optics. And so I just figured, well, I better learn about management. I know a little bit about optics already. And so then I became basically like an engineering manager most of my career, product development.
Did you, I'm going to interrupt you, so I apologize, but it sounds like you've covered, already at this point, by the time you got your degree in studies and then practical experience in management, you've gone through a huge range of optics applications, right? So starting in astronomy and then including lasers, but medical optics. What's the common thread? Was it just that it's all interesting with the physics? Because, I speak to people who are just optical designers.
Right.
And maybe it'll change what the application is, but they just do design or they just do lasers. So I'm really curious to hear what kept it interesting.
What kept it interesting? So a year out of college, I met my wife, and that became very, very good for me. Now we've been together like 40 years.
Congrats.
And then our son was born a couple years later. And so then, you just got to keep things going. Our families were not close by geographically. So we just, had to have a good job, and we didn't want to move. So just getting different jobs locally in Southern California in driving distance. And it just kind of worked out that way. I mean, people would contact me and say, hey, would you like to come and work over here? Or someone would make a referral. And that was very good and interesting. So that happened. And then, and sometimes because the economy would change or a particular sector would change, like the telecom industry right around 2000, it was booming and then it busted. I was working for Corning, an advanced photonic technology group, and the stock market was going crazy. If anything was, fiber optics or anything, they were like going nuts. And then they realized that there was too much fiber optics already, and then it all crashed around. So even when I was in healthcare and things, things would change. And so I'd have to go look for something else to do. And so it was very interesting, very diverse technologically, and not geographically though.
Right. And that to that point, I guess your work is it's engineering. Like, you were operating as an engineer.
Right.
Did you, I assume so, because you kept with it, but did you enjoy that switch towards management? And is it much different, or kind of what is the difference?
Well, I'll tell you this. So as I was getting my technology management degree from Pepperdine, I was working for Johnson & Johnson dealing with intraocular lenses. So I was designing multifocal intraocular lenses, dealing with all the testing of those, helping marketing and sales, because there were people that said it'll never work. Obviously, they were wrong. It works like very, very well. And I was promoting it for many different ways. So my boss, my director, he said to me one day, Don, you're going to have to choose. You either get to go the technical route or the management route, but you can't do both. And I said, well, I want to do both. I always want to be doing stuff in the lab, but I think I need to be in management, because otherwise other people will be in management and I'll be a little disappointed. And so, and that turned out not to always be true. But at that point, about 30 years ago, it was definitely true. And it continued on for some number of years until I went to work for a company called PI, Physique Instrumenta, as a senior applications and sales engineer here in Irvine. So their U.S. headquarters are in Auburn, Massachusetts, and their global headquarters are in Karlsruhe, Germany.
Huh.
And I knew about this company because I had been a customer of theirs, and a good friend of mine had the position that I was to have. And he decided he was going to leave and go back and do more, engineering. He was a little bit more electronics guy, but a lot of control systems and things. And so I said, well, I would like to come and have that job. And so I talked to the president, and he said, yeah, that sounds good. You come and do this. And so I did that for 10 years. And there I really didn't do much management. And I did a small amount of engineering, but I was really able to go out and help lots of different customers in lots of different fields apply our technology, precision motion, nanometer technology with piezos and micro positioning, and 6 degrees of freedoms, the hexapods, Stewart platforms, fiber optic positioning type things, many things that I had worked on before. And I really enjoyed doing that, being able to go out to both industrial customers and education and research customers, national labs, and really help them out. So that even broadened my experiences more, which was very enjoyable for me. And it wasn't until another old friend of mine, who I was helping, I always kind of help people recruit and get good technicians or engineers into their places, or managers. And he had a position for a technical service manager. And I had worked with him some 20 years before, same kind of business. And I always thought it'd be nice to work with him again. And so after 10 years of working at PI, I decided I would go and work with my friend again. And that's what I did until I retired. And helped kind of put some things together and help kind of get the succession plan in place. And he's looking forward to retiring, I think, maybe also in the next year or so.
Yeah. Yeah. It's funny you say that. I just got back from a multi-week trip, getting to visit customers some of our European customers for the company I currently work for. And it is a really different, obviously, but it's really different getting in front of customers, talking to them and saying, how do you use this thing? It's one thing to engineer it and say, well, I know exactly how it should be used. And then you talk to a customer and they're using it in a totally different way, or have totally different needs than you might anticipate. For me, it's always really invigorating to get to have that back and forth. But I've also spoken to other engineers where it's not so invigorating. So I think maybe it's person to person. But anyways, so I think simultaneously throughout this career, you also were involved in outreach and volunteer work. Is that correct?
Yeah. So I guess one of the things I learned as a manager was that, you got to hire good people that have skills that are needed: optical engineering, optical design, hands-on assembly, test, measurement kinds of things. Lab skills are always good to come by. Being able to write a report, do the normal kinds of things. And so I always seem to have, where do you look for people that know stuff about lasers and optics and fiber optics and these types of things? And so I got involved with the Optical Society of Southern California about 30 years ago because one of the engineers that I hired, also a U of A grad, and he had worked with another friend of mine that I knew, so hired him to be an optical engineer. And he was a member of the Optical Society of Southern California. And when he said, "Donn, you should give a talk, we could have a meeting here." And I said, "Okay." And so we had a lot of single point diamond turning machines and compression molded, injection molding, a lot of test and measurement, big labs, beautiful manufacturing places. He said, "Well, we could do a tour. I'll do a presentation, tell them what we're doing with multifocal lenses and silicon lenses and things." And so I did the presentation. We had a cafeteria, so we had dinner. And then we had tours. And at that point, I think, again, it was just like, wow, these are great people. I like these people.
Yeah.
And so I've been an active member almost the entire time. There was some time when my son was, I guess, in middle school, high school, and I wanted to spend a little more time with him before he went off to college and things. But definitely the Optical Society of Southern California was really what helped get my Optics Institute started, probably about 10 years later in 2003. Mm-hmm. And the reason for that was because there was a mission. Part of the mission for the Optical Society of Southern California was to do education outreach and scholarships and that kind of thing. And I thought, well, I'll be able to do it, do that better if I start an Optics Institute of Southern California. And actually, while I was working for the Gemological Institute of America as the GEM instrument director, we had microscopes and spectrometers and polarimeters and things like that I was helping to redesign. We went to the GEM show in Tucson. So every year they have a big GEM show in Tucson. And I had this idea of starting my own Optics Institute. Yeah. And I went up to Jim Wyatt's office with my wife, and he was the director there. It wasn't yet its own college. And I told him that I wanted to start this Optics Institute of Southern California to do education outreach, K through 12, maybe the community colleges and stuff. And he just listened to everything I had to say. And then at the end, he said, "I think that's a very good idea. I think you should do that. And then after you get some success and you get some students that are getting ready to go to college, you send them over to the University of Arizona." And I said, "I will do that. That sounds great." And then he actually told me to go see a couple of professors over at USC, Ellen Wilner and Sandy Sawchek. Huh. And so I did that because I had no idea. And I went to talk to them. And Alan Wilner, he said to me, "You need to give a presentation at ETOP, which will be in Tucson, like in October. So I was probably there in the spring at USC. And I said, well, I really don't know what I'm doing yet. He goes, it doesn't matter. You just need to go do it. You need to prepare something and do a presentation about what your Optics Institute is going to do. And I said, okay. So I did it. And it just really helped launch everything. So I would say that part of the moral of that story in my life is listening to my mentors, because they're more experienced than I am. They've been around longer. Typically, they're older than me. And so even my physics professors at the University of Arizona were phenomenal. And I listened to them. Like one of my professors who's not with us anymore, he was a scruffy older guy, kind of, the long hair and a beard, but he always wore a shirt and tie.
Right.
And like a skinny little tie, because he was probably from back in the 60s.
Yeah.
And so as president of the Society of Physics Students, I was, in front of the students that would come there introducing the speakers and stuff. And one day I was wearing my overalls because I was a student, right? It must have been winter time, right, in Tucson, so it was cold and wearing overalls. And the yearbook photographer came in and started taking pictures. Okay. Well, I got a picture of myself in the yearbook in overalls. So
perfect.
I don't do that anymore. Actually, I have a shirt on today, and a lot of times when I go to meetings, I wear a tie. They're all like SPIE ties, all optics kinds of things. So they're very nice conversation starters. Even if I go to non-optics meetings, people look at those. Well, that's an interesting tie, and it's a conversation starter and talk about optics and all things very interesting and technical. Yeah. So listen to your mentors. That's something I always tell the young people, and I always try and do myself.
So I really appreciate that. And how do you find a mentor? I think like that, the necessary requirement to listen to one is you have to find one first. So do you have any tips on that?
Well, great question. I actually have a slide that I've used many times in some of my career presentations, and it's about mentors. And there's probably 8 or 10 mentors that I've had, photos of them, including my high school astronomy teacher, my 2 physics professors, some of my key managers that have hired me, some more than once. I was hired twice by 2 different people. So those guys were my mentors. They liked me enough to hire me twice in my career. So that was good. And I think it's kind of just a serendipity. You have to keep your antenna up. And when you find someone that you like to listen to, then listen to them. Matter of fact, here's another little tidbit I tell the students when I start talking to them. And I tell them, every moment of your life, you have a choice. You can, if somebody's talking to you, you can either decide to continue listening to them or not. And if you don't want to listen to them anymore because you don't like what they're saying or whatever, you can say, excuse me, I need to go. And then you just go do something else. But if you like what they're saying, then you keep listening. And then you decide, well, do you want to contact that person again and listen to them more? And if you do, then that's kind of how you find your mentors. So I think the key point is listening. As we were talking about going to customers, the most important thing I found about talking to customers is to listen to the customers. Ask them questions, open-ended questions. What are they trying to do? What is their big challenge? What's their problem they're trying to solve? Listen as much as you can. And then if you have something to say about what you've heard in response, then go ahead and let them know what you think. But make sure you listen. And the more you listen, the more easier it is to find whether it's good colleagues, good customers, mentors, even, like when I met my wife, right? I listened to her. and I still listen to her. Try not to talk too much.
I'm newly married, only a few months ago, but I've already learned that lesson. So
Yeah.
But I definitely take your I really like that approach of kind of being fairly open-minded and unbiased, of not seeking out perhaps this is a mentor, this is what a mentor looks like, but rather who is it that you're starting to mesh with, maybe that you have some resonance with, that probably implies keep hanging out with them, keep listening to them. So and you've said it, and we'll share the slides that you mentioned as well as some other links to your institute. But it's hard to overstate how valuable a mentor is, in my opinion. And it sounds like likewise kind of for yourself. So
yeah.
So
let me mention one other thing. Whoever's going to be listening to this podcast later, as part of the Quantum Economic Development Consortium that I'm a member of, I'm on the Workforce Development Technical Advisory Committee, and so
easy one to remember, right?
Right. So it's a QEDC TAC.
Yeah.
Right. Technical Advisory Committee, acronyms, right? It's a government kind of sponsored thing, but also very much private enterprise. They're probably the bigger sponsors. So we have a office hours where we pair mentors with students that are looking to learn something about how to get into the industry. And so I was kind of reluctant to do that, but they kind of wrote me in. I think I'm going to do it. I think it's this week. I'm going to spend an hour or something online with a couple of students, and they'll ask questions and I'll give them whatever guidance I can. And some of it might be technical, but some of it might be the flavor of what we've just been discussing, right? Because I can be an online mentor, but it's really important to have, people in real space and, next to you in person kind of mentorship that, maybe you're going to work with, or they're going to be your instructor or something.
Yeah.
That's really important. Absolutely.
I think that, the internet and video calls have been unbelievable, but face to face it's just different, right?
Yeah.
And what you can get, or much less having a mentor, like if you work with them, being able to, doesn't have to be beers, but in my case, it's often been going out and getting a beer and talking through something.
Yeah.
It's just a different experience. So you started up the OISC?
Right.
Did I get the acronym right? All right.
Institute of Southern California, right.
Yeah. You started this up, and you had some experience through teaching labs and other things with doing education, but had you had kind of a formal, what was the extent of your formal, I know what I'm doing teaching, or was it?
So when I was in college in the physics department there at the University of Arizona, I think somehow one of my professors, Professor Shea, I guess he was my advisor, and no, he must have been my academic advisor. So he was also tasked with teaching introduction physics labs for freshmen and sophomore. And so I guess my junior and senior year, he asked myself and one of my friends who was the same level, also in engineering physics, if we wanted to teach, freshman physics labs. And we said, sure, what do we do, right? And so, we had been in taking labs, the whole time. As an engineering physics student, you basically have 4 years of physics labs. You never have a semester where you're not doing a physics lab. And so, we kind of knew the ropes, and they laid out, these are the experiments, these are the worksheets, you just guide the students through it. And so I already had 2 years of that experience. And I was also working at the Optical Sciences Center as a technical, student. And so I would just help the professors and the grad students do whatever they needed done. And it was a great learning experience, both for the hands-on experiments at the Optical Sciences Center and also hands-on teaching in the physics department. And so I just learned it, did it. And then when time came to start teaching as a professional, I guess I started teaching at the community college, Irvine Valley College. They had a laser technology program, so I was on the advisory committee there for a while.
And this was before OISC.
Yeah.
Okay.
It was before OISC, and then right after I started OISC, I kind of became an assistant director, a volunteer director, and then also started teaching. When I teach introduction to optics, geometric optics, physical optics, fiber optics, and then a friend of mine asked if she could come and teach lens design. And so I said, well, sure, because we were very loose with everything. We had a very nice facility for a little while. And so she taught a year of, it was like introduction lens design. Then it was kind of optical systems engineering, and then optomechanical integration. So there were 3 courses she taught. And then and then, in the middle of it, they had us move the facility to a new facility that they had built. And things kind of management-wise went a little bit sideways. And so I decided to take what we had been teaching, the lens design stuff, and we transitioned that over to UC Irvine. And that was the beginning of the UC Irvine Optical Engineering program. And then another friend of mine, Dr. Brian Monticelli, he took over the program at Irvine Valley College, been very, very successful with that. And then during COVID, because he's been working up at the Jet Propulsion Lab, we moved it up to Pasadena City College. And now, he's still cranking away, just getting, 15, 20 students in every cohort. And
oh, wow.
Yeah. I mean, it's a really good program. Incredible. Yeah. So there's something like 45 schools around the country, community colleges, that have some kind of program like that. And a few of them also have optics fabrication. And that's what we're trying to do more with the AmeriCom program now. So we're trying to set up another community college program in Santa Ana that will teach precision optics manufacturing technology. And then if we get that going, and that's funded in good part by the US government. So if that happens, then we can expand that to include, laser technology, fiber optics, maybe some quantum things. So there's a whole nother path forward that hopefully will get underway later this year. And I think I mentioned we're having a panel discussion up at the SPIE Photonics West on Wednesday about this program, how to, what's the ecosystem like for the next generation optics technicians.
Is that this coming Wednesday?
A week from Wednesday.
Okay.
A week and a half.
Okay. Well, fingers crossed. I'll have this uploaded before then.
Great.
But even if I don't, we'll definitely provide a link, because you sent that, and hopefully people can kind of retroactively look into it some more.
Yeah.
I've got a bunch of questions I want to ask. I guess one of the first is, I think this is a multi question, but it's really often that you tell someone that you're in optics, they think eyeglasses, and you kind of do the education process, and by the end of it, if you're lucky, they say, "Wow, that sounds really crazy, like really high tech," and if you're unlucky, they kind of, your eyes are glazed over and they say, "I'm not going to talk to this person again." Who are you trying to get into the precision optics manufacturing courses, for example? Because I think from the layperson, you hear about optics and your takeaway is, oh, you must be a weird, science aficionado, and it's this strange realm of people. And I think that's not true. So I'm curious who the target audience is.
I totally agree with you. It's not true.
Right.
So I'll give you some examples of target audiences, people that have interests and experiences in either their vocation, for example, machine shop people, auto mechanics, plumbers, electricians, anybody who's working with their hands, also like people making jewelry, for example, artists, people that have an interest in real things, making things. And particularly, so this program that it marries well with the manufacturing technologies, and most particularly people like machine shops. So I mean, if you go, there's hundreds, maybe thousands of machine shops, small ones, some larger ones across the country. Many companies have their own machine shops just to build things. There's actually a place in Costa Mesa here, not far, called the Urban Workshop. And the Urban Workshop is a community facility where they actually have courses on machine shop technology. It's like a big maker space. The Optical Society of Southern California is going to have a meeting there in March, and our guest speaker is going to be from the company Rivian,
cool.
who makes the electric cars and vehicles. And I think it's a lady, and I think she's going to talk about all the optical sensors that are in these types of vehicles. Because if you're driving a car that has sensors in it, and you don't get too close to the wall, it beeps and beeps. Well, those are optical sensors. And there's lighting, outside lighting, inside lighting, all kinds of optical things going on in these vehicles. And I think that most people don't understand technology much. I'll give you an example. When I'm talking to young students, high school students, middle school students, I hold up my cell phone. And everybody knows what a cell phone is. And I ask them, well, how does a cell phone work? And they go, oh, well, you just turn it on and you touch it, and that's how. No. How does the information get from your phone to your friend's phone? And then they just look at me like, what? Never thought of that, right? And then somebody will say, if it's a group of students, they'll say, oh, Bluetooth or Wi-Fi or satellite. And it's like, well, what does that mean? I mean, those are words, but what do the words mean? What is physically happening to get the information from one phone to the other phone? And then maybe somebody will say radio waves. So that gets them a little bit closer. Of course, it's microwaves, and there's a little transmitter receiver in every phone. And the cell tower also has that, or if it's a Wi-Fi inside, it's a similar concept. And so then it gets them thinking. And then every cell tower has fiber optics that go from the top of the mechanism where the transceivers are under the ground, down the pole, under the ground, to a whole network of fiber optics that's all over the world, under the oceans. I tell them, under the oceans, there's fiber optic cables. And they look at me in disbelief. They don't believe it. I'm like, look it up on the internet. There's huge ships with big, spools of fiber optic cables, and they just lay them down into the ocean. And it's been done over and over again, and it works. And so, from optical sciences perspective, we tend to understand that because we've studied it, we've learned it, we've been in that industry, and actually been, aware of these things and maybe teach these things. So it's a very interesting way to try and get young people, or all people, lay people, anyone who's willing to listen, to understand what's happening. Now, one of the other interesting things that I've been kind of involved with, studied and written about from time to time, is the history of science and the history of optics and our technologies, and how those technologies have been instrumental in building modern civilization. And so, just like telecommunications and computers, without optics, wouldn't exist. Even biology, right? Without the microscope, we wouldn't understand biology. And so I tell people that, and then they look at me like, that's kind of interesting. I wonder what else I don't know that I can find out about, right? That's interesting. And you can make good money doing this stuff. Right? And so it's interesting, it's fun, there's really amazing people, and you can make a good living at it. And and try not to be afraid of the math, because you're supposed to learn math, when you're in middle school, and of course high school and college, you should learn some math. And sometimes I think it's unfortunate how some people teach math. And my son actually got his degree in applied math, his undergraduate degree. And not even sure why that happened. It just, that's what he wanted to do. And so he got to do what he wanted to do. And he does a lot of computer stuff because he grew up, with a computer in the house that we could open up, take apart, and put back together and improve and stuff.
Mm-hmm.
So not having any fear of the technology is really important.
Mm-hmm.
But and so I'm fortunate because I get to work with some schools locally here that have some really great instructors and good facilities, and the students, while there's a great diversity of students and their interests and their capabilities, those that tend to want to listen to what I have to say are the ones that, get to benefit from learning about these technologies.
Yeah. It's interesting. My background's in large optics, fabrication and metrology, and it's really interesting, right? You kind of
Did you work with Professor Kim?
I did, yeah. Daewoo was my advisor.
Did you know a young man named Bo Wang?
Yeah. He's
I mentored Bo. I still do sometimes.
Oh wow.
But, yeah. Bo is a great young man. I'll tell you a short story about him because you mentioned
please.
that. So one day I'm sitting in my office at PI and I get a phone call, and it's Bo, and I'd never met him before. And he found me on the OISC website because he went to the University of Rochester, studied biomedical engineering with a minor in optics, because his father and his grandfather were both very involved in optics.
Mm-hmm.
And then he went to law school for a year, and then he decided he didn't want to do law school. So he came back to California where his parents were living, found me, and asked if he could volunteer for my optics institute. And I said, sure, come on over to my office and we'll talk about it. So he comes over in a 3-piece suit. And I thought, well, that was very impressive. And if you've spoken to him, he's extremely articulate.
Yeah.
And I was just kind of blown away. And I said, okay, all you got to do is show up at, these outreach events that we're doing. And he showed up to every one.
Yeah.
And he came to the Optical Society of Southern California meetings every time. And I introduced him to some of my friends, that have optics companies and stuff. And one of them hired him as an intern or something like that for, it was going to be for a few months. After a month, he had learned so much that they decided they had to hire him or he would go to one of their competitors and take some secrets. So he stayed with them for 6 or 7 years. And then he actually took a job at Rivian about a year and a half ago or so.
Huh.
And so that's why we're having a speaker from Rivian, because Bo, I think, was probably the youngest president of the Optical Society of Southern California. And then because of COVID, things were messed up, and he became president a second time, which was the first time since 1951, when the OSSC was started, that we had a person be president twice. And now we currently have another gentleman who was president during COVID. So it was all virtual. So we had him be president again so he could do the in-person thing, because in-person is so important when we're having these meetings and meeting people and doing this kind of work in optics. You cannot manufacture optics or teach optics manufacturing online.
Right. Well, and I mean, you've talked a bunch about your lab work. I think lab classes or hands-on things are invaluable. You can take all the courses you want, but getting your hands on it and doing it, it's totally different. So
yeah, when I was teaching geometric and physical optics through the UC Irvine program, we started off, it was in person back in 2009. And at some point then they said, oh, we should try and do this online. And I'm like, okay, how do we do that? And then I thought, well, let's try hybrid. We'll have the instructor in the classroom, we'll have students in the classroom, and then we'll just live stream it. And we did that for a couple of years. And then the university said, well, everybody just wants to be online because of the traffic and everything. And we have to pay for the room. So we'll make more money if we don't have to pay for the room. So let's just go online totally. So we did that. But in teaching geometric and physical optics, I had to find a way. They had to do labs.
Yeah.
And so I found low-cost stuff from like Anchor Optics and just pieces. So the lab parts would be just like a couple $100.
Yeah.
And they'd have to buy the book. And but it worked out really well, so they could learn about the different lenses, hold lenses, mirrors in their hands, prisms, diffraction gratings, polarizers, so all the basic things they could do. And then they would have to take photographs with their cell phone. And then they would send me their lab write-ups.
Huh. And it worked well?
Yeah, it worked great. I mean, I had them make pinhole cameras.
Yeah.
Right?
Yeah.
And little telescopes, so it was really amazing what they would come up with. Spectroscopy. They could learn about introduction to spectroscopy with little, 20-cent, 30-cent diffraction gratings from Rainbow Symphony.
Yeah.
I mean, I love those things. I've given away thousands of those little diffraction gratings for students. I'm going to do it again on Tuesday. I'll be at a little middle school doing what is it called? I don't know. They call it Cougar Chat. So I'll be in front of a few dozen students and talking to them about careers and who am I? How did I do my career?
Yeah.
And give them time to ask questions. I'll give them diffraction gratings, maybe some polarizers or something.
Mm-hmm.
Show them some laser pointers.
Yeah, I love. My wife used to teach math for kind of middle school and elementary school students, and one of the things that you had mentioned, everybody has to learn math, optics, geometrical optics, and quantum optics. For me personally, that was the first time math became really tangible. You can say like, well, it's useful to know fractions to calculate the tip or something. It's not so useful anymore.
Right.
But like optics, you no pun intended, you see it. With geometrical optics, you see it, and it's just, that's crazy. Like how well the math maps to it. What's the difference, I guess, in what appeals for, someone like someone attending courses at like the community college level or the university level versus middle school or younger? I know you do courses for K through 8 or materials for that as well. So what appeals differently and what appeals the same? So
I would say that I would call it the advanced high school level and community college level are similar from the material and the math part. And the community colleges, you can actually get a lot more equipment. But I'm actually going to be teaching at a high school introduction to lasers and fiber optics. So I got some kits and actually curriculum from a company in Phoenix called Industrial Fiber Optics. So they actually sell educational kits, which seem really good. And I've done a lot of these kinds of kits over the years from Newport Corporation and things I make my own. But these guys are really kind of complete. And my goal is to, I'll teach it for a while, and then hopefully someone from the school will be there with me and learn how to do it. So maybe a younger, mid-career, early career teacher that, can pick it up and do it. Mm-hmm. And that's kind of been my process all along, which, is so how to do that. So at the middle school level, it just has to kind of be, very low cost lenses, mirrors, even like funhouse mirrors, diffraction gratings, double slit experiments. You can do things that kind of like freak them out,
Right.
I mean, diffraction is, I have a really nice spectroscopy exhibit that I take to the schools and do a display. And so they can actually see the spectrum of like a mercury light source, neon light source, hydrogen, and they see that and they've never seen it before.
Yeah.
And it's like, what is that? And it's very colorful, it's very bright.
Yep.
And it just captures their attention. There's a little motto I have that I stole from like a Toshiba company, printer company. I went to something years and years ago, but it's very simple. First, if you're dealing with students or any group of people, you have to interrupt what they're doing by some way. So having a very colorful light exhibit is one way. Then you have to entertain them. So interrupt what they're doing, then entertain them and make it fun and interesting for them. Then you have to really keep their attention, and then you can educate them. So, interrupt, entertain, engage, and then educate.
Yeah. Get them to buy in, right?
Get them to buy in, get them to want to learn what's happening.
Yeah.
There's so many different pieces of the puzzle.
Right. There's it's really amazing, I think. And like you said, there's tons of different ways to get people to buy in, but once they do it, it's off to the races in my experience.
Yeah, I'll give you another interesting example. So I mentioned early on that I started in astronomy, and I built a telescope when I was in high school, a 8-inch f8 Newtonian. I bought the optics and built the tube and the stand and everything. Bought the mounts, and so I would take it across the street to this park, and I'd point it up at Jupiter and Saturn and the moon and Venus and clusters and stuff. And anybody that would walk by, I'd be like, "Hey, check this out!" Right?
Mm-hmm.
And I bought a camera body, an Olympus OM1, and I took pictures of Saturn and Jupiter and the moon and stuff through my telescope. Brought it over to Tucson and had it there, and eventually it's gone now, but. And I kind of thought, I went to a lot of astronomy, public outreach things and with the kids and did a lot of that. But a lot of times the kids were disappointed because they saw the pictures like from Hubble telescope and they're expecting to see pictures. It's like, that doesn't happen.
Yeah. I'm going to see the man on the moon, right? Like smiling, waving back at me.
And that's not reality. But with lasers and optics and things, well, they can see cool stuff right there and then, right? Polarization, right? I mean, there was a lot of educators, mentors of mine and others, would put together different things. So I would pick from here and pick from there. And a guy named Steve Jacobs from University of Rochester. Well, there was Steve Jacobs at University of Arizona and another one at Rochester.
Oh, okay.
Both of them were mentors of mine.
Oh, okay.
And they're both gone now. But Steve Jacobs at Rochester had this optic suitcase. And so I got one of those back in 2003 from him. And then I eventually modified it and made I had several different versions of it. And I continue to use those kinds of concepts, polarizers and diffraction gratings and lenses and mirrors and, all these different things when I go out to do the outreach to the students.
Mm-hmm.
So the interesting thing is that sometimes astronomy is a little hard to get kids interested and keep them interested, but I find that optics and lasers is maybe a little easier to get them interested in. However, I'm very interested in getting another telescope, and I just found Celestron, which has been making telescopes for decades. They're just coming out with a brand new one called Orion, and it's completely remote control capability. Matter of fact, it doesn't even have an eyepiece to look through. And the idea is that everything's controlled by your cell phone, and then you can stream from your cell phone or project from your cell phone onto your big screen TV in your house. So I just realized, okay, now I can do this in my local community, in a local facility where they have, indoor, outdoor, party type places.
Right.
So I think at some point, maybe this year, I'm going to get one of those and start playing with that because I want to have it for myself. For my house, we have a nice patio. We have nice clear skies over here. And so back to the beginning, astronomy again.
Yeah.
So it's kind of full circle, which is a very nice thing for me. And I think my wife will like it. And I think people will really like it because now you can see what the telescope is looking at on a big screen TV, and the software can actually do just like the professional astronomers do, take time lapses and then basically superimpose or stitch together. I have the light buckets continually capturing and then display. Do the a little bit of the false color if you want, or there's lots of different software things that they can be done. So it's really exciting. And they partnered with a friend of mine, or actually my friend's younger brother, who got his PhD at Caltech and started a company called anyway, they're researching and developing mining the asteroids.
Oh wow!
So they partnered with Celestron, and they have this 6-barrel telescope, hunting system for hunting for asteroids and stuff in the sky, space junk and all that.
Yeah.
And it's Celestron's very proud of it. So I'm trying to get the guy who's the CEO of Celestron coming to an optical society meeting, and maybe they'll come and talk about that particular project, because it's really quite cool.
I mean, and you said before kind of the history of optics. I think astronomy and kind of gazing into the sky.
Yeah.
It's the foundation throughout human history of just sparking like wonder, right? Oh my God, there's stuff up there.
And rainbows.
Right.
What's a rainbow?
Right. And why is it happening? Yeah, absolutely.
And rainbows, I think, led us to spectroscopy.
Yeah.
Right. And so I use that a lot. Matter of fact, I have a presentation for middle school kids called Rainbows, Atoms, and Humans. Right. And how are they related? And what's that all about? So there's a quantum aspect to it, but really, kids can make their own rainbows if they have a little sprinkler in the sun at the right angle.
Yeah.
So, and then diffraction gratings, to give them the diffraction gratings and, get their minds going.
Yeah. And there's an author I really like, Neil Postman, who wrote a book a long time ago about television and how it has an impact. But I think one of the takeaways is he's talking about education and how you get more technology and it provides a lot of opportunities. So like you're saying, being able to stream your telescope to your TV with these enhancements has a lot of improvements, but also, getting those hands-on things and getting those things that, like you said, kind of disrupt your day-to-day, disrupt your, like, everything's normal, everything works, the cell phone just works. What about this? That's really key to getting someone to like pause and start to think about it. So
yeah, and let me just share one other thought about that. So while that telescope is highly automated, I also want to buy and get just a regular telescope that they can look through.
Right.
Compare the differences. So, for example, in near Pasadena at Mount Wilson Observatory, they have a 60-inch telescope and the famous 100-inch Hooker telescope that Edwin Hubble made photos and did spectroscopic information about the the movement of the galaxies going away from us, right? And so now that's open to the public. Both of those telescopes, you can actually reserve time and have a guided tour and a night viewing. And so the Optical Society of Southern California, we've done that several times over the years. We take a group of like 20 people or something up to for evening of, we get up there and we do the, potluck dinner kind of thing, and then get the tour of the whole, mountaintop a little bit, and then the tour of the inside of the telescope, the history. And then when it gets dark enough, then they open it up and we start looking through the telescope at different globular clusters or binary stars or whatever it is. And it's fabulous.
Yeah, that's cool.
So if you come out to Southern California, you got to check this out.
Yeah, absolutely. I already wanted to go to Southern California just to relax and hit the beaches, but that's even more motivation. So
yeah.
So I want to kind of shift towards the end of this and ask you about your quantum optics and outreach in that area. Before I do, I'd be remiss though. I do want to mention I just had I think you'll enjoy this. I just had a really fun experience the other week. We were downtown near the courthouse in Tucson, and I grew up. My mom worked in the courthouse, and there was always this really, really cool thing that at the top of the courthouse you would see a rainbow. And I'm walking around near there with my wife, and there's a placard that says there's a huge diffraction grating, diffractive effect made by Stephen Jacobs, the Tucson Stephen Jacobs. And I told her about when I met him, and he was just sweetest old man. Just walked up to me, asked if he could sit at my table at the College of Optics to eat lunch with me, and he gets to talking. And for anyone listening who's thinking about going into optics has this bizarre effect where it's a small community and you talk to people and you find out who they are and you go, oh my God, oh my God, I'm speaking with like someone, a legend, right out of history. and it's just a normal person. So anyway, Stephen Jacobs was just an absolute sweetheart. But
yeah, that's true. So I worked for him for a year, and my job working for him is I was an undergraduate physics student, and my job was to collect experiments, physical material, and notes from professors, because Steve Jacobs was putting together an advanced optics lab for graduate students.
Yeah.
So I went to the different professors he told me to do, and I would come back with a box of material and some papers that, kind of describe what I'm supposed to do. So I had to set up the experiment and try and get it to work, and then, see how it is and write it up, and that's what I did. And I learned so much by doing it. I learned about fiber optics. I learned about prism coupling into waveguides, optical bistability.
Yeah.
Just amazing technology in it. I didn't know, I just was doing what I was told, following the professor and the other professors and the graduate students. I don't know if you know Glenn Borman.
I'm not familiar now.
He's a graduate from the U of A many, many years ago, around the time when I graduated. And he's been a professor. He was at Creel for a while, and I think he's in South Carolina. He was the SPIE president. Anyway, he taught me how to cleave fiber optics by hand, because we didn't have fusion splicers or any fancy cutters. We just had a little diamond tip and tape.
Yeah.
And we would clean off the buffer and try and get to the cladding, and then nick it and then break it and check it and see if it was flat.
Wow.
And I made one of the first polarization preserving fiber optic interferometers right there in his lab, because he got these sample fibers. Steve Jacobs got them from Roger Stolen at Bell Labs. And so Roger Stolen sent them to Steve, like, see if you can test these somehow. So it was like, well, you should be able to just put in polarized light, make sure the orientation is right for the input, make sure the orientation is right for the output, and they should interfere. And so I had this big 50 milliwatt Heaney laser from Spectrophysics. It was old. It was like 6 feet long, big glass Heaney tube inside, probably about a 5 millimeter diameter beam, and a microscope objective, aluminum block on the optics table with wax to hold the fibers on. And I just blasted the light into the two fibers, twisted them around on the in and the output, and it worked. It worked.
And
amazing.
Yeah. And that's another thing, like you said, optics has such a fun, tangible aspect to it. You get your hands on things and you move it and it clicks, and it's just like, what a feeling. So
it's really amazing. And so the quantum aspect of all of this is yet a whole nother world. A laser is a quantum device by default. Right? And there are many things. I mean, even semiconductors, right? Those are quantum devices, a transistor, right? But now the second quantum revolution is involved with entanglement, teleportation, superposition, and, in all the different types of qubits that people are making, and how to maintain their quantum states as they travel from point A to point B. It's very exciting for me to see what's going on at the University of Arizona and their partners in the whole quantum world. And sometimes I wish I would have stayed in Tucson, but then I wouldn't have met my wife.
Right. Yeah.
So that's just how it is. And I'm just very fortunate to be here. And I really appreciate you having this opportunity to do this interview and this podcast, because it's very nice. I really appreciate it. I really like talking with you. I hope to meet you in person very soon.
Oh, definitely. I as I said, I will take any opportunity to visit Southern California. So.
Well, just give me a call, look me up, and I'll spend time with you, take you to some nice universities or companies, and there's amazing things here.
Perfect. That sounds great. So if you have a little bit more time, I want to kind of dive into your work on the quantum outreach. And optics already sounds confusing. Quantum, I think, at least in my experience, when you say it to people, it sounds downright scary, right? It either sounds scary or like some kind of spooky thing, that, etc. what does it mean? What's the tangible impact for the, the random person who doesn't know it? Why should they care about it?
Great question. So one of the things that I think is most important is cybersecurity. And the reason why there's a second quantum revolution is because humans figured out that if they build a quantum computer of enough power and capabilities, they'll be able to hack all current encryption technology.
Mm-hmm.
So currently, cybersecurity without the quantum aspect of it is a real mess. And people are getting hacked every day, all day long, all around the world. And, and there's a lot of things that people can do to prevent it just using normal cybersecurity methodologies. And they just don't do it because they don't know about it, or they're whatever the reason is. So people get hacked all the time, and hackers are always trying to hack more people, get money out of it.
Right.
And that's what's happening. So with the invention of Shor's algorithm, which is the thing that'll help hack known encryption technologies using a quantum computer, now there are post-quantum cybersecurity, if you will. How do you protect against a quantum hack? So there's already solutions for that in quantum key distribution and post-quantum cybersecurity algorithms. And there's a little bit of a competition, it seems like, between those two methodologies of protecting against a quantum hack. So with that, though, there are the ability to use quantum computers for the benefit of mankind, which can do calculations and computations that classical computers, even supercomputers, will never be able to do.
Mm-hmm.
And part of that is modeling atomic level, many body problems, molecular structures, drug discoveries, and financial securities, financial investment portfolios, logistics, agricultural things. The list is very long of potential applications. And then there's also the opportunity to do quantum secure networking. So we have the current internet, so there can be, and already are, some small versions, prototypes of quantum internets. And what does that mean? You can connect different quantum computers together. You can transport information and data across networks that are quantum safe. So those are things. And then there are quantum sensors, atomic clocks, and so many different ways to use this quantum phenomena, quantum entanglement and teleportation, to improve sensitivity of many different types of sensors.
Mm-hmm. Mm-hmm.
So it's a small self-selected group of people on the planet that will learn about quantum things and decide that's what they want to do, because they're able to do it and they're curious and they just want to do it. Now, there'll also need to be all kinds of people to support those scientists and engineers and technicians, the administrators, the marketers, sales, quality assurance, all kinds of different people, just like in every other industry, like in the semiconductor industry.
Right. Deployment, everything.
Yeah. It's just all kinds of people are needed in this nascent industry we call quantum.
Yeah, you anticipated my next question. I mean, it sounds like it's not exactly correct, but it sounds like roughly the change, at least with respect to quantum computing, will be equivalent to the change from pre-electronic computers to post-electronic computers, except probably larger.
Right.
And my question was going to be, do I need to be a genius who is steeped in quantum information or studies to participate in it? And it sounds like no, that's not the case.
Yeah, that's absolutely correct. I think I even have a slide here that here it is. No, that's not the right. There's a slide that I got from the quantum computing group at UC Berkeley that talks about all the different, not all, but many of the different education and career opportunities around quantum simulation, communications, quantum algorithms, machine learning, quantum chemistry, etc. but there's another slide that I have somewhere. I don't know where it is. Anyway, basically, it's just that all the different people that are involved in any type of human endeavor are needed in the quantum industry as well.
Right.
I mean, even the people that build the buildings. I met an architect the other day here in Southern California, and he said that he helped design a optics lab down at UC San Diego.
Yeah.
One of the professors there, right? And so he's the kind of person, well, he's not into quantum or optics or anything, but we need people like him to help design the labs that we're going to be doing, whether it's educational, research labs, company labs. When I was at Corning, I had to build, pilot production labs and R&D labs.
Yeah.
So you got to kind of start from scratch and figure out, well, what do we need and how big is it and how many tables and how many optical benches and what kind of equipment goes on everything and how many people do we need in there to run it? Does it have to be a clean room? All that kind
how
of
stable, at least from my background with optical fabrication and testing, it needs to be really stable if you have a big test tower. And you're right, that's your construction folks need to figure that out. So so how does one get involved? How do you participate or learn more about quantum to kind of take part in this coming revolution in terms of the workforce?
Well, that's an excellent question. I think I have a good answer because I've been asked that question before. And so I created a web page on my website under miscellaneous called Education and Career Assistance. And it has links to various career assistance and job search websites for physics, optics, photonics, and quantum fields. And also, I serve on the board of a local nonprofit called VitalLink. And VitalLink works with the local schools, the school districts, community colleges, K through 12, and the local industry communities, and links them together. They are the vital link between academia and industry. And so we have an optics exhibit that I put together, and we take those out to the schools. So on my webpage, there's stuff about education and careers, a link to the IEEE Photonics Society, and an older optics education directory from 2019 to 2020 that was a joint thing from OSA and SPIE. I guess they discontinued that, which is unfortunate, but it has most of the schools globally that teach this kind of technology.
Oh, cool.
And there's a lot. So there's very many in Southern California, obviously Arizona, Montana, most states and many countries have colleges and universities where you can go and learn this information. And then there are career websites that have job postings. And again, I have links like to Optica, SPIE, Physics Today, Physics World Careers, quantum computing jobs from a company called Quantum Computing Report. They keep that up, quantumjobs.net. QEDC has a jobs board. So there's many opportunities. And if somebody is listening to this podcast and they don't know where to start, but they're interested, you can contact myself or Logan. Go to my website at oisc.net.
We'll have a link to that in the notes as well, for sure.
Perfect. Yeah. I'm about to update it to be QOISC, and we'll see how that goes. But I had a young high school student at a local school doing free design services for logos and things. Yeah. I said, well, I'm really into quantum optics, so design me a logo that's different than the logo I have. The Optics Institute has a logo I created 20 years ago because I needed something very quickly, and it's just stuck. But we might update that. So.
Okay, great.
Yeah.
Well, great. I think that covers kind of the formal questions I wanted to ask. And if you're up for it, I'd like to ask a few kind of random questions to close it out. So how should you learn? If you're a student of any age, do you have any tips on how to learn? How to learn. And sorry that these will be kind of strange questions.
That's okay. Well, that's perfect, because as it turns out, I'm probably a little bit prepared because I'm going to go and talk to some middle school students on Tuesday, and they gave me some prep questions. So I think the most important thing for a young person is to find out what they're really interested in, right? So find out something you really love, and then find a way to learn more about that, and find out what people are doing in the real world. Maybe there are jobs that do what you want to do. So find out, think about yourself, think about what you like to do, and find a way to do it. And then you will learn all about whatever it is you're really interested in.
Yeah. I think, again, kind of getting that buy-in makes learning easy. And if you're passionate about the field, then it makes it a lot easier than if you're not.
It's like not working.
Right, exactly. Which is hard for a lot of people. You mentioned this early on, and I strongly agree that a lot of times, unfortunately, education, math being one of the most common ones, it's like, oh, math. And it's really unfortunate that the approach has led to that. But anyways.
Yeah, I think one of the problems we have as a society, and even as a human race, is with the modern technology, the cell phones, the televisions, is that it gets the people's minds going places that aren't all that productive for themselves or for the rest of society.
Right.
And that's a little unfortunate. And that's why my 4 things about, interrupt what they're doing, because what they're doing is putting their face in their Facebook or their phones.
Yeah.
And that's what you have to interrupt them.
Yeah. Right. So on a different one, you ended up settling in Southern California. I can't blame you. Does it matter where you work? If somebody goes to university and says, I really love Southern California, or I really want to go work in Europe or whatever, does it matter? Does it limit your career, in your opinion, or what do you think?
Well, good question. I think it probably doesn't limit your career. I think, in my opinion, in my experience, I like Southern California. My wife likes Southern California. We once had an opportunity to move to Florida, Jacksonville, Florida. She said no, and it was no. We stayed in Southern California, and that was a great thing. And so, and I think now more than ever, you can kind of live wherever you want.
Yeah.
And if you decide that where you live is your high priority, then you find something to do to, have a job, make a living wherever you want to live. And making conscious decisions like that is really important. When people go with whatever the flow is, then they get kind of stuck. And there's a lot of that on the planet. People are, you can see about, the border crossers, people that are trying to move from one country into this country because they think it's going to be better here. It may or may not be better here. I don't know. But sometimes, wherever you are, that's where you are, and you just got to deal with it, right? And if it's good, it's good. If it's not so good, because there's plenty of great people in Mexico doing just fine, or in Colombia, in South America. People all over the world figure out things to do.
Yeah.
And unfortunately, some of them, don't. And
yeah.
That's why I kind of try and help as many as I can.
Right.
But, each individual person only has so much reach into the community.
Yeah. And I think that, at least in my experience, you can, if you look for it, there's going to be opportunities. Optics extends everywhere. So there's going to be some opportunities to kind of get involved or explore it further just about anywhere. So
yeah. And like I said, on my website, under education and career assistance, all these links have education and career opportunities globally.
Right. Okay. Yeah, which is fantastic. I had that's the other question I had. Do you have, this is kind of a 2-part question, but do you have advice, I suppose, for someone in industry, not only with respect to, I guess, maximizing your time in industry, but also maximizing your experience in optics and the optics community, right? It's a small community in the sense that it's small and everyone kind of knows each other, but it's huge. So do you have any advice kind of for how to well participate both in the workplace and just in the community in general?
Yes. So the answer is twofold. One is get involved with the professional societies of your choice, whether it's IEEE, Optica, SPIE, physics societies, whatever it is, chemicals, biological, biomedical, whatever it is that's go find your society that's interesting for you, the like-minded people that are studying that.
Mm-hmm.
And there are national groups and global groups, but also try and find local chapters. And if you're a student, participate in your student clubs that are interesting to you. And if you can't find one that's interesting for you, start one.
Yeah.
And see if there are other people. I mean, all you need to do to start a club at a school is, have, half a dozen of your friends that are interested in the same topics, and then go start your own club.
Right. Yeah. Yeah. I love that advice.
When I last academic year, I reached out to the local high school. Actually, it was the end of the year before, and I gave these presentations on quantum. And two young ladies decided they wanted to start a quantum club at their high school during their senior year, and they did it.
Cool.
And I came and, we had different speakers, and we took them on a few field trips, and it was phenomenal.
Yeah. I love that advice, and it piggybacks off of advice one of my mentors has given me. I think maybe he's given it to me more indirectly, but it's, at some point, just do it. Like if you think it's a good idea, just try it. And that goes a long way to advancing you. So, well, I don't think I have any more questions. I really appreciate you taking the time to talk to me. Do you have any last thoughts or?
It's just been a real pleasure. I've been very fortunate in my life to have found astronomy and used that to launch into my physics and engineering and optical sciences, and had a great career. Had a lot of great friends. I still have friends from college years, and that's been fantastic. I love going I'll be up at Photonics West. I'll go to the U of A College of Optical Sciences reunion, and I'll just see many other people. So it's what I do for fun. These people are my friends, and we help make this human experience better. And one of the things, I suppose, I grew up on Star Trek, and we have Star Wars, and we have these science fiction programs, and those are kind of the goals, right?
Yeah.
I mean, is it the goal to have humans travel the universe or the galaxy or something? And how could we possibly do that?
Right.
Because we don't have physics now that understand how we do it, but maybe quantum computers will help us develop new physics. I mean, people are continuing to get better understanding of the world we live in, and what are the actual physics laws, and how do we improve them and modify them, and will we ever be able to travel faster than the speed of light? I mean, who knows? I mean, it's not possible. Well, it's not possible now, but maybe when your grandchildren are around, maybe they'll do it. I don't know. So that's why I like to always reach out to the young people and instill that concept that things that are impossible now might be possible in the future, because 200 years ago, nobody ever thought they'd be flying around in airplanes like taxis.
Right.
If you told somebody that, they'd put you in an insane asylum.
Right.
Because that was just nuts.
Or even
going to the moon or going to Mars or something.
Yeah. So I have to ask, you open it up. Are you the original Star Trek or the next generation Star Trek? Which
I grew up on the original Star Trek with William Shatner and Leonard Nimoy and all the crew.
Yeah.
When I was back in the 60s, I remember sitting at the foot of my parents' bed, watching the TV. And it's like, wow.
Right. It's it's funny. I grew up watching The Next Generation with my mom, and kind of similar to what you're describing. It captures. I think it's a little more rare to have that optimistic science fiction these days, but it just captures such an ideal that really captures your imagination and kind of what to push towards. So
yeah. And as I have a SPIE T-shirt that has a glass half full of water, and it says, an optimist says the glass is half full. Pessimist says the glass is half empty. An engineer says the glass has excess design capacity. An optical engineer says by optical path measure, the glass is much more than half full.
I like that.
Yeah. So that's one of my favorite SPIE T-shirts.
Yeah. Well, Donn, it's been a pleasure.
Thank you.
I absolutely want to take you up and meet in person sometime. And
if
otherwise,
when I come to Tucson, I'll look you up there too.
Definitely. Absolutely.